Good evening. Come on, wait. My name is Michael Lockett. This is my mechatronics project right now. This is a smart device, alarm, temperature, thermometer, heater controller. If you look at the screen here, it's 11:43 p.m. and it's going to shuffle between time and temperature facts. All of those are controlled by a variety of sensors that I have inside. I'll show you in a sec. One thing I want to showcase here is if I hit A, it asks when we're thinking. A stands for alarm. The time right now is 11:44. So if I hit 11:44 and I change my mind, right? I want to go to 5. No. It has backspace, enter. In the morning, yeah, man, or yeah, right. We're going to go, yeah, right, because we want it to go off right now. It says, whatever you say, boss, we'll see you at 11:44. That's what my alarm sounds like right now. Buzzer and blue LED indicate the alarm setting. Right here, if I hit B, you're not gonna believe this. It was like 0 Fahrenheit last night. It's gonna shuffle through the low temperature that it hit and how many times it turned on the heater. If it's above a certain temperature or below a certain temperature, it will say something funny like equip the drip, as in put on your best clothes. C is the heater control, so it's gonna go, so no heater. I say 1, you're fired, or 2, that's all you. We're gonna say, you're fired. It says you don't pay me. So now I've turned the heater off, and I can turn it back on anytime I want. Let's say I'm going through an alarm and I change my mind, I don't care about this anymore. D will take it back to the default screen and we'll shuffle through that again. Moving on, we'll take off the top case to showcase the inside here. This is the alarm and buzzer components. We have the blue and the red LED, blue for alarm, red for heater, the buzzer in the middle that makes that noise. Here's my LCD screen. They all sit as close as they can to the top without actually making contact from the other components here. If I carefully remove this guy, emphasis on carefully, I can hopefully showcase how all of these pieces work together. So, with those both off, you can see large breadboard here is where everything shuffles into before being wired into the Arduino. The membrane on the top takes up a ton of those digital pins. Here's my RTC, and right there, in this little slot that I've made for a cutaway, I have the temperature sensor. I didn't want it to read the internal readings, so I have it on the outside, on the opposite end of where the heater will be. Motor was a bit of a challenge, right? For 2 reasons. 1, power. It had to have its own voltage supply because the Arduino couldn't handle it. Trust me, it overheated one time. It scared me, it was terrible. I ran it directly to the driver from this external power source, and then the driver then goes to the motor. All of the other pins that control it, you can see ran across here into the digital pins. When I have this motor turned on, I've just turned it off. What it should do is move that arm down and make contact with this button that will sit next to it on my nightstand just in front of my window. So anytime it will hit less than 50 degrees, Arduino will tell the motor to go ahead and turn on the heater. That will last for about 30 minutes before it turns it off 30 minutes later. And then it shuffles every hour. It will be able to do that once. It will keep track of how many times it does that and then report back to me in the morning as soon as the alarm goes off. I'd like to demo the motor for you, just so you can see how it will work. And also explain one of the pitfalls that I ran into a little late into this project. I'm gonna make contact with that power button, and then, I don't know, maybe we're lucky this time around and it will work, but until I can figure out what makes that button do its thing, I guess I could probably repurpose the arm. Show them. Give me a second. There you go. And then, red light comes on to signal that the heater's been pressed again. I've tried a lot of different methods to go ahead and simulate the human finger. Current and voltage wise, nothing has worked so far. What you see right now is a little soft pad wrapped around the side of the lever arm. It's got a copper wire and a ground cable running through a 1M resistor. So far that hasn't done it, so I have plans to change some of the resistance that I intend on using. But it might just be a matter of fixing or swapping out what kind of heater I have. Anyways, that's kind of the gist of it. It was really fun to make, and I really like how the print turned out.